AI models are continually becoming more capable. They can reason through complex problems, write code, analyze data, and make decisions. But that capability alone doesn't make them useful in production. A model by itself is stateless. It processes one request, produces a completion, and forgets everything before the next turn. It can't take action in the real world, access real time information, or coordinate across a multi step workflow on its own. This is why so many modern AI systems are being built as agents. Agents work like this: the model gets context, including the system prompt, the user prompt, any relevant information or memories from previous interactions, and a tool list. It reasons over the information in the context and decides whether or not it needs to call any tools. If so, the tools get executed and the results get fed back into context for the model to reason over. This cycle repeats until the task is complete. This is the agent loop. But that loop doesn't run itself. Something has to manage it. That something is the agent harness. Coding assistants are some of the most common examples of agent harnesses today. They're models wrapped in systems that give them tools, memory, context management, execution environments, and the ability to operate in a loop. And on top of that, a good agent harness helps verify whether the actions an agent took actually worked. The same patterns that are used to build resilient and capable coding assistants can be applied to any other agent use case as well, like customer support systems, research agents, workflow automation, and business operations. Together, the model and the harness create an agent. Here we're importing agent from Strands, creating an instance of the agent, and then passing in a prompt to that agent saying, explain what an AI agent is in 2 seconds. Let's give that a run by typing Python 3 simpleagent.py. And we can see the response coming back. This is already a working agent. Not a very capable one because it has no tools yet, but it already contains an agent loop. The model receives input and generates a response. The model itself isn't autonomously managing this process. The harness is repeatedly invoking the model, executing tools, updating context, and deciding when the loop continues. And once you start adding those tools, memory, lifecycle controls, and other capabilities into this harness, the agent becomes much more powerful. You may have heard of prompt engineering, which focuses on defining the instructions, examples, and constraints that drive model behavior. Context engineering focuses on deciding what additional information beyond the prompt enters the model's context window, when and in what form. Harness engineering is the layer above both. It's the process of creating and tuning the runtime system that orchestrates the model, manages context, connects tools, enforces rules, and provides the compute, memory, and observability that keeps the agent operating safely and effectively. The goal is to let agents handle more on their own, while you maintain control over the boundaries. You can run deterministic code where you need predictable behavior, add validation layers to verify outcomes, and when the stakes are high, you can interrupt a running agent and bring a human into the loop. We'll be exploring how to build agent harnesses using the Strands Agents SDK, which is an open source SDK that gives you the building blocks to construct your own harness and control it end to end. It has components for tools, context engineering, lifecycle hooks, plugins, memory, session management, evaluations, observability, and more. You compose them together into whatever system your use case calls for. But Strands also ships with pre-configured defaults that can give you a capable agent out of the box, including built-in tools for file operations like shell, search, and web access, automatic context management that compresses proactively, and sub-agent delegation. You can start with those defaults and then customize further or build from scratch using the primitives. We'll do both in this course. Strands itself came out of production systems at AWS. Teams building agents kept running into the same problem. The abstractions and rigid orchestration layers in existing frameworks weren't keeping up with what newer models could do natively. So Strands was built around a simple idea: let the model drive. You give the model tools and context, and the model reasons through what to call, in what order, and when to stop. Your job is to define the environment, capabilities, the boundaries, and the guardrails around the model. The model's job is to reason through the task. So now let's take our very simple agent and add some tools. In this example, we are creating a market research agent that helps a company compare internal product listings to their competitors. Here at the top, we import agent and tool from Strands along with some built-in tools from the community tools package like HTTP request and file write. Then we define a custom tool. Custom tools let your agent run deterministic functionality directly when it needs it. This could be calling an API, performing business logic, doing math, reading data from a database, or whatever you need. It's simply a function that an agent can run. You can also use MCP, but we'll get into that in a later video. You can turn any Python function into a tool using the tool decorator. This tool simulates querying a product database to pull back information about a company's product listings. This in the real world would query a database or hit an internal API to bring this data in, but for now we're just getting used to the mechanics of the SDK and seeing how to create a simple agent. Strands reads the doc string and uses it as the tool description that the model sees, or it can read the type hints and generate the input schema automatically. You write a Python function, add a decorator, and Strands handles the rest. Now to create the agent. Here we create a simple system prompt. This prompt lays out the behavior of the agent. It defines what the agent is and how it should behave. This gets sent along with every request to the model. In this case, we are saying you are a product research analyst and providing details on how to handle tasks. Then we create an agent by creating a new instance of the agent class, passing in the built-in tools like HTTP request and file write, as well as our custom tool, query product database, and then also passing in the system prompt. And now we can give the agent a task by passing in a user query or prompt just like this. Research what wireless headphones are trending on the market and compare it against our offerings. Write a short competitive positioning summary and save it to report.md. Now we can go ahead and give this a run. The agent kicked off and we can see it using its tools like HTTP request and query product database to look up the products that it's comparing. But the interesting thing is you can see that when it runs into errors like having certain websites be blocked for scraping, it pivots and uses a more accessible public data source. This is showing how the agent loop allows the agent to be adaptable. And whenever it runs into errors or problems, it runs through another loop and it's able to take a different path. Then later, we can see that it continues to gather information and then it goes to write the file. Here it's stopping to ask me, the user, for permission. Can I proceed with writing this file? So this has some built-in human-in-the-loop capabilities with the file write tool. I'll go ahead and say yes to allow that. Then it will write the file to a local directory, which will contain the entire report. To see what the agent did in more detail, step by step, we can inspect agent.messages, and this will show us the full context of what the agent saw and did with every loop. Let's go ahead and run it again. The agent is done running and we've printed out all of the messages that the agent can see. And when I first started building agents, this is what I wish someone had shown me first because it answers the question, why did my agent do that, almost every time. If we scroll up, you can see every user message, every assistant response, which is the response coming from the model, and you can also see all of the tool calls and the tool results that occurred during the agent loop. You can see the tool use blocks where the model requested a tool with specific inputs. Then Strands invokes those tools and sends the response back to the model as additional context. The model reasons over those results and decides what to do next. This accumulated conversation state is sent to the model on every request because models are stateless by default. They only know what you send them during every single invocation. The harness continually manages and reconstructs context, so the model can build on previous actions, recover from failures, and synthesize information across multiple steps. Throughout this course, we'll progressively compose primitives offered by Strands agents into more sophisticated systems. The early videos focus on understanding the components individually with small examples. Then we'll build towards more advanced architectures like long running conversations, memory systems, orchestration workflows, customer support agents, multi agent systems, evaluations, monitoring and observability, and cloud deployment patterns. The goal here is building a mental model for how agent harnesses work and how these core strands primitives compose together into real systems. In the age of AI coding assistants, syntax matters a lot less than understanding the systems and the patterns. To get started, install Strands Agents for the core SDK and Strands Agents Tools for the Community Tools package. Also, by default, Strands uses Amazon Bedrock as the model provider. So if you already have AWS credentials configured, then you're ready to go. But Strands is model provider agnostic. You can also use providers like OpenAI, Anthropic, or Ollama for local models. In the next video, we'll take a closer look at different model providers. I'll see you there.